Neptune is the most distant planet orbiting our Sun, a world defined by its isolation and extreme cold. It barely receives enough energy to spark a reaction in its atmosphere, yet it remains home to a climate of pure violence. The winds here are the fastest ever recorded, reaching over 2,000 kilometers per hour. This creates a planetary contradiction. On a world where the temperature sits at minus 214 degrees Celsius, these supersonic storms shouldn't have the fuel to exist. Somewhere beneath the blue methane clouds, a hidden engine is at work, defying the laws that govern every other planet in our system. Unlike what its distance might suggest, Neptune isn't a completely frozen, inactive world. Deep within the planet, there is still heat left over from its formation. Even now, Neptune radiates more energy than it receives from the Sun. That internal heat slowly rises upward through the planet's thick atmosphere. It pushes gases around and feeds the massive systems above. So, while the surface appears distant and lifeless, the planet itself is far from quiet. There is a constant flow of energy coming from below and giving those violent winds a source that has nothing to do with sunlight. Having a source of energy is one thing. Turning it into supersonic winds is something else entirely. With the heat rising through Neptune's atmosphere, it creates powerful differences in temperature and pressure. Gas begins to move from one region to another, and those movements start to build into large-scale flows across the planet. But unlike Earth, there's no solid surface to slow those winds down. The moving gas doesn't lose speed since it continues to accelerate, stretching across vast distances without much resistance. At the same time, Neptune's rapid rotation begins to shape these flows. As these currents interact and build on each other, the motion intensifies, eventually reaching speeds beyond anything seen on any other planet in the solar system. This is where Neptune's most powerful storms begin to form. Within these fast-moving layers, large storm systems begin to take shape across the planet. Some appear as dark regions in the atmosphere, massive enough to stretch for thousands of kilometers, while winds circle around them at extreme speeds. One of the most well-known examples was the Great Dark Spot, a storm first observed by Voyager 2 in 1989. It was comparable in size to Earth and showed all the signs of a massive, stable vortex. But when astronomers looked for it again just a few years later, it was gone. That disappearance revealed something unusual about Neptune. Even its largest storms don't necessarily last. New dark spots have been observed forming since then, sometimes in completely different regions of the planet. Each one follows a similar pattern. It appears, becomes more defined for a period of time, and then begins to break down. Because of that, Neptune doesn't have a single long-lived storm like Jupiter's Great Red Spot. What it has instead is a cycle. At any given moment, the atmosphere is active in multiple regions. Storms are developing in one area, while others are already fading out. The result isn't a steady pattern, but a constantly changing system that never fully settles. All of this is being driven by winds that are stronger than anything recorded on any other planet. Even among the gas giants, Neptune stands apart. Jupiter and Saturn both have powerful atmospheres, but their winds don't reach the same extreme speeds of Neptune's 2,000 km/h winds. Part of that difference comes from how the energy inside Neptune moves through its atmosphere. The heat rising from below doesn't spread out evenly, and instead builds stronger contrast between different regions. That imbalance pushes the atmosphere harder than what we see elsewhere. What makes Neptune unusual is the combination of these effects. It isn't just one factor, but several working together, allowing the atmosphere to reach speeds that no other planet in the solar system seems to match. Speeds like that are hard to truly imagine. Hurricanes on Earth at their strongest can rip through cities. Now picture something hundreds of times faster that stretches across an entire planet and moving constantly with no pause. There's no build-up to it. Those winds are already moving at full speed all the time. There isn't a moment where things ramp up or settle back down, because this isn't a temporary event or a passing system. Even with all of that, Neptune still doesn't fully make sense. Scientists can explain parts of what's happening, but not all of it at the same time. The wind speeds are extreme, the energy source is there, and the atmosphere clearly responds to it. But when everything is put together, the full picture doesn't line up as cleanly as it does on other planets. Some models can recreate the winds, but struggle to match how they behave over long periods. Others explain the energy, but fall short when it comes to the structure of the atmosphere. Each piece works on its own, but combining them into one complete system is where things start to break down. This is what makes Neptune different. It's a planet where the explanation is still incomplete, even after everything we've observed. And recent observations have only made that harder to explain. Between the years 2003 and 2018, scientists tracked Neptune's temperature over time, expecting to see gradual warming as the planet moved through its seasonal cycle. Instead, the data showed the opposite. Over those 15 years, much of the atmosphere cooled by around 8 degrees Celsius. That shift didn't match the models. Based on Neptune's position in its orbit during that period, temperatures should have been slowly increasing, or at least staying relatively stable. Instead, the drop was consistent across large regions with no clear cause behind it. Then, between 2018 and 2020, another change appeared. While most of the planet had been cooling, the region near the South Pole began to heat up rapidly over a much shorter period of time. Neptune isn't just another gas giant with stronger winds. It behaves like a different category of world. Most planets are shaped heavily by the sun. Neptune isn't. Its atmosphere is driven from within, which changes how everything works. It's a reminder that even in a system we think we understand, there are still places that don't quite fit the pattern.